Kansai Science City, also called Keihanna Science City, one of Japan's leading international R&D centers, is located in rich natural surroundings across 3 prefectures, Kyoto, Osaka, and Nara. It has more than 110 research institutes, universities, and companies, and a major housing project. It's the perfect environment for demonstrating advanced technologies and research into eco-friendly systems. Currently, it's home to the important Keihanna Eco-City Smart Community project. The project is demonstrating research achievements in 4 sectors: residential, commercial, transport, and community energy management. In the residential sector, HEMS is being used in 14 houses. These systems manage electricity, gas, and other energy sources, demonstrating energy savings, lower CO2 emissions, and other benefits. In summer 2012, the project confirmed sales of solar-generated power can be increased by regulating storage batteries during peak shaving times. Some 700 households also use smart meters and tablet terminals. Large power demand response mechanisms can intelligently control power demand using communications technology and new electricity billing plans. During a demonstration in summer 2012, power demand was controlled by simulating increases in electricity rates during peak hours. In the commercial sector, a BIMS in Keihanna Plaza optimizes the use of electricity and heat while demonstrating energy savings and lower CO2 emissions and other benefits. In the transport sector, 100 electric vehicles are now in use. Peak shaving and peak shift approaches are achieved by recharging at times and locations as requested by the Electric Vehicles Management Center. V2X technology mechanisms have been applied to electric vehicle and reuse storage batteries. Effectiveness is being demonstrated to optimize plant facility power demand. Finally, in the community energy management sector, the project is demonstrating community-wide optimization of power supply and demand using a SEMS as a total energy management solution for issues like demand response-based orders for households, buildings, and electric vehicles. In November 2012, a comprehensive community-wide demonstration began linking SEMS, HEMS, BIMS, and the Electric Vehicles Management Center.
電力消費量がリアルタイムに分かりますので、無駄な電気をですね、消すっていうような行動ができるようになりました。具体的にはですね、天候によってですね、電気の消費量が多いとかですね、電力消費量のピークの時間が分かるようになります。それによって電気をですね、消すというような行動になりましたので、省電力の効果が出たのではないのかなと思います。
The SEMS and customer EMSs, in other words, HEMS, BIMS, and the Electric Vehicles Management Center, engage in the following exchange. The customer EMSs make demand forecasts based on past energy use data for each household, building, and electric vehicle, as well as power generation forecasts for solar panels based on weather data. They then send planned power transmission reception values for the following day to the SEMS. The SEMS gathers data sent by customer EMSs and calculates a planned power transmission reception value for the community. The SEMS uses this value to set targets for power transmission and reception, taking into account power demand controls and requests for cooperation from power grid operators. The SEMS allocates target power transmission reception values within an adjustable range to customer EMSs and notifies them. The HEMS, BEMS, and Electric Vehicles Management Center use terminals to communicate these values. Customers use power in accordance with the target value displayed on their terminals as part of demand response. The SEMS monitors actual transmission reception in the customer EMSs. When the target value diverges too much, the SEMS issues a same-day order to the customer EMSs to close the gap. When demand response is complete, the SEMS issues points based on how close a customer's power use came to meeting the target value. You can see how the project is optimizing energy supply and demand balance in the community. The Keihanna Eco-City Smart Community Project is working with the community to demonstrate electric vehicle recharging systems using 100 electric vehicles. Anticipating the day when electric vehicles will be commonplace, the project wants to learn about power demand during recharging and demonstrate the effects of demand response in terms of the peak shaving and peak shift approaches. The Electric Vehicles Management Center keeps tabs on the remaining charge, location, and past use of each of the 100 electric vehicles to predict their recharging power demand. The center then uses these predictions to recommend recharging schedules to drivers through the vehicle's navigation systems or email, or to ask them to recharge at designated locations. The results inform the center's understanding of recharging peak shaving and peak shift effects.
家で太陽光発電なり、あるいは何らかの発電をしておいて、そして蓄電池に貯め、そして帰ってきたらこの車に充電すると。たくさんの電気を使わないし、これが未来の車だなっていう感覚が乗っていると湧いてくるような感じで、非常に楽しんでドライブをしております。
Using ICT-based energy management, the Keihanna Eco-City Smart Community Project is building a sustainable, smart community model for application in Japan and abroad.